Hi, this is Showman Roy. I'm not good in PowerPoint presentations. As you can see, this is an empty PowerPoint with something called live pod. Now, generally, I tell everyone that I'm not good in PowerPoint because in the past, the type of people that I work with, they're extremely good on making presentations. And I feel myself really not up to their level. So that's why I always consider myself is not good in PowerPoint. Now, they used to say that if your PowerPoint have too many text, you rather use Microsoft Word, not PowerPoint. So that's why my presentations are mostly graphical. So the live pod. So let's say you have a production environment. There are certain servers, there are applications that has the UI, people are using it, and your UI server connects to the app server, and that may have the database, some batch processor, and for doing like nightly jobs, and then may have now you have the firewalls, like one is for the external, one is internal, and so that you actually have multiple zone, so that UI servers are public facing, but the app server and rest of other servers are in your private network. So those are internal, and you may use some cloud solutions as well. And when the traffic increase, you now have to increase the servers. That means you have to deploy the new servers, you have to make sure that you configure them and make it ready, and you have to scale up both vertically and horizontally. So let's say for UI, the more servers you're putting, you now need to balance them with the load balancer, and then you also have to increase your app servers as well to balance the load, and also you need internal load balancer as well. Now this is a typical like server scenario where you have your own data center or maybe hosted virtually on the cloud, but still you have to have a lot of like time consuming effort in order to maintain these things. So that's the whole purpose of this the live pod. And now you wanted to also now, let's say, deploy this one as an additional similar disaster recovery, or for release management, you actually deploy entire set as an inactive or dark side pod. So all these things you have to replicate. It is time consuming. Now imagine this one, that we do have the live, this whole environment that just you have for your applications, and everything that you have is the desired state. You put that in a configuration file, like a configuration file, that's the manifest of your desired state of the environment. This manifest is then you apply to the something that's called Kubernetes. This is the power of Kubernetes. You define the entire environment as a YAML file or JSON format. You can put that either a JSON or in YAML, and you actually distribute that, everything that I just explained, and apply that automatically, and give that the JSON file to the master node of the Kubernetes, and that automatically start putting the pods one after the other like this. This is nothing but, like, I can compare like this, that these are the two different environments. You have one side the servers, the other side the pods. The pods are automatically is all connected using load balancers, both internal and your external load balancers, and they're all connected. So that side is the Kubernetes. This side is your environment. It can be on your local, on your on-prem data center, or maybe on the cloud virtually. But still remember, this is all, it takes a lot of your time, it is expensive, and it is laborious. So obviously these are, this is expensive. Now the whole thing is now can be done through the Kubernetes orchestration services. Now the beautiful thing about this is all can be done using the manifest file or the YAML or the JSON format. The definition of the manifest can give you the entire infrastructure in minutes. So that's pretty much what I'm going to demo now. So here I'm going to go to this YAML file that I was showing, that it is a kind of a deployment, and you can see that it has the information about what is the name of the pod that I'll be creating, what are the labels on that, the container, what is the name of that container, where that container, what image it is coming from, all this information. In a different video, I'm going to explain you in details, but right now this is the YAML file. So let me go ahead and deploy this one. So I have the window already running here. So let me clear this. So I have the YAML file. So I'll be using kubectl and going to apply this. So let's first find out if there is any pods. So I'm going to say get pods. So you can see there's nothing at this moment and there's no deployment. So now I'm going to say get nodes. Let me see how many nodes are. I have one node right now. So this is the node I'm going to deploy. So kubectl, I'll be using kubectl, and I'm going to apply the file that is the worker that I have, deployment YAML. This is in my Visual Studio, you can see that, and I'm going to deploy that. And within a minute, you can say it created that. So now if I say kubectl get pods, you can see that it is already having the pods ready. Now I think because see right now I'm running this on so let me read on this one more time, and I wanted to actually restart because you can see the CPU cycle is too high. That's why it is taking quite a long time. I may be running too many things here. So let me reset the Kubernetes cluster. So let it run, make it everything clear. So and you can see it's really utilizing 100% of my CPU cycle because I'm doing the video recording at the same time I'm doing this demo. So hopefully it is going to so while it is coming, let's see quickly this YAML file. This is I have the two different, if you can see that, I have two different pods that I'm deploying here. Actually, you can see that. So one pod is, I'm naming this one as Showman PowerShell, and I'm putting some labels there. Okay, so I'm putting some labels, like this is my PowerShell, and this is release is March 2018, so that next release, if I make some changes, I'll be putting, let's say, August release or so. And I'm using the image that I created. I'm going to explain you how I'm creating that. So let's quickly go back. It's almost starting, so let's see. So I'll be having everything, pretty much nothing will be there. So deployment will be empty. So let me go ahead and see the status. So I think let me see the node. So it's getting ready, and you can see that my kubectl. So you can see get context. I do have two type. I do have Minikube and the Docker for desktop. So if you see that, I can, the star is there next to that's the current context, but you can say you can also, which is the current context, so you can say that Docker for desktop is my current context. So now let's see if I can get nodes. This is the node deployment, there's nothing, and pods are nothing. So now let's go ahead and apply this. It should be fast because I just restarted. And now if you see get nodes, same thing, but pods, there are two pods are running. And if you see the deployments, these are the right now. So I have requested one. So this is how easy. You can see that I just created two pods, and going back to the presentation. So I just deployed two pods, and that's pretty much it. And if you see the services, let's get the services. And these are the two, one is the load balancer, one is the cluster IP. I just get those two services as well, because all those things are like a service in Kubernetes. And in the file, you can see that I do deploy those services here. These are the type is service, and one is the load balancer, and one is the actual network. So that's how it is, how easy it is to deploy. Now, if I have to scale up or down, I'm going to show you that how easy is that one. So if you want, let's say right now you have only two pods. So if you can say get pods, you'll see there are only two, and both are running. They're running two different applications. And now I'm going to have, let's say I wanted to increase one each to two. So I can specify that replicas, let's say I want two. My desired state says that I want two set of nodes, two pods for each application. So I'm going to change it for each of them, say replicas as 2. Now all I have to do now is to rerun the same YAML file, and you can see that how quickly it says unchanged, and there is a configuration change. So it just did this one, and now if I go back and say get pods, you can see that it is still, see, its container is creating right now. The other two is just started. One is pending, one is container creating, and you can see once, because my CPU cycle is too high, because of that it is taking a while, but eventually you see that now one was pending, but now it is creating, and then if you run after some time, you'll see that both pods are absolutely running. All the new pods, every pods are running the applications. And now I'm going to go over that how I actually created the application and deployed and doing that once. So let me quickly see my the CPU utilization is too high because I actually running too many things here on this machine. but you see they are all the 4 pods, they're running right now. So now let's say if you want to go back to the old state, you can just say this is 1 and this is 1, and just deploy that, apply the same manifest file as an YAML. So it is going to take care of that change again. So now let's go back, see and show you how I actually created this one. So the master node, when I apply the manifest file, it actually goes to this one. So this has the API server. So this is the commands. You can use the commands, or even the manifest file as a JSON or YAML file. You can give it. The tool that I'm using right now is called kubectl. So using this, you can give the instructions and the desired state that you want to the Kubernetes and API services that are running there. Either depending on what Kubernetes where you're running, it pretty much have the similar API servers, and the controller and the scheduler and the different components of the Kubernetes that are really designed to support your infrastructure. And it automatically create the nodes, and depending on the desired state that you are looking, it automatically put the number of pods in each node and all the services it will run, and so that your environment will be up and running in no time. So here is an example what is the different component does. Once you have the desired state of that you want for your application or your environment, it actually keep on monitor it. So there are various components like the kubelets that are part of each pod that communicate and to the master to make sure that they give them the status of the pod. Whether it's a pending, there are only 3 states: pending, and then it is running, and then it is failed. So if it is failed, so let's see, if we have let's say application 1, and that's we give this application 1, it automatically creates number of pods for that application and distribute in multiple nodes. Let's say similarly we have application 2, it goes to various nodes, and application 3 that goes to various nodes. So typically what happens is, if for some reason, let's say one of the applications started consuming too much memory, and it is or resources in that particular node, the controller of the orchestration of Kubernetes orchestration automatically make sure the other pod that is on the same node, it take it out from that node and put it somewhere else. And then it also take care of, let's say there is a failure, there is one of the pod failed. It automatically, because our desired state, depending on how many pod we are, our expectations are, it automatically spin up the other one and then it takes care of the bad node or the bad pod from the system. So it will always make sure that whatever you desire, it is available for you. So here's a simple example of what is a pod. A pod is nothing but with a certain components that comes with it, and the container. The container is an image that you create of your application that runs within the pod. A pod can have multiple containers, but typically we prefer to have one pod with one container. And so here's an example of the application that I can talk about is the service bus. Let's say we have a service bus with topics, and let's say there are topics that are coming, like one by one different messages are coming with various topics. So to handle different type of messages, we can create containers. So one for the container here may handle one specific type of message of topic, let's say the brown topic, and the other one is to support the green topics. So these two containers are having our application to support those messages. What we have to do is package them inside the pod and deploy to Kubernetes using the YAML. Now, if for some reason we have a high volume of load in our service bus, what we have to do is literally increase the replica set the way I was showing you there in the YAML, and increase the number of pods so that it can actually handles the load properly. Because if you have 1 million load messages in your service bus and you need to handle them, maybe you can put thousands of pods in your cluster or in your the nodes that or environment you have. Increase the number of nodes and then say, I want to have thousands of pods of whatever the topic or the message type that you are receiving that you need to handle. You can just increase it. Now you can also use the kubectl auto scaling option, that is depending on the CPU or you can increase the number of pods automatically. You don't have to run any command for that. So let me demo you how to create this one. So the application is, let's say I deployed this application. So I have a message, let's say I have three applications. So I have, let's say one application is called CLI dispatcher, maybe the brown type of topics that's going to handle. So if you see the program files here, all it is doing is in the service bus, the topic is CLI dispatcher, and this is just going to handle that CLI dispatcher messages. And similarly, I have PowerShell dispatcher, another application. This is the PowerShell dispatcher messages. So when I receive the message, all I have to do is I have to process that message in the PowerShell, right? So all I'll be doing here, this one, let's do this one. So I'm going to say publish this one to a folder. So I'm going to publish this. So you can see that it is right now publishing, and I'm publishing this to a folder called PowerShell dispatcher folder. So this is where I'm copying. So let me launch. So this is where I just deployed this one, and now for this I have created a Docker file. So let's see how the Docker file looks. So all it is going to do, it is creating a .NET Core image it is taking, then it is installing the PowerShell there, and then from the whatever the application folder that I just put it, you can see this is here. I just put right now the newer version of the DLLs. It is going to copy to the image, and then entry point will be the DLL that I'll be running. So let's see if I can. So let me show you this one. This is the DLL. So output of this one, if you see this particular property of this project, this is building a DLL, which is the output is the application, the DLL, So let me make sure that is the right DLL it is. Okay, so the power dispatcher DLL. So this is the DLL that I need to start with. So that is the entry point. Now what I'll be doing, I can go to this one. So you can see that I already may have the same image. So let me remove the existing image. So Docker, let's say this is the remove image. And now I'm going to run this this Docker build. So Docker, I'm going to build this image, which is I'll tag it as Showman v1, and in the same file. So this is the Docker file. So I can see that it is going to run the, and you see it is copied that and made this entry point here. So in order to run this Docker, so I'll say Docker run. The image that I'll be running is Showman v1, and you can see that it started running. Now in order to see this one it is running, what I'll be doing, I have written another application. This is the application is going to simply put the commands onto the service bus. So you can see it is, so let me run this application, and it is going to send a message, and you see the moment it receives a message, it is running and processing those messages, and it is running from within the actual Docker container. So it will be processing and executing whatever the PowerShell that you wanted to give.